another conic section, and I would want you guys to recognize this as an ellipse because we have x squared. Sure, there's extra stuff in there, but we're not going to worry too much about that. We have the y variable squared, and there's a plus sign in between them, so that tells me it's an elliptical conic section. And as we saw in the previous example, we do want one side to equal 1, but that's already the case here, so I won't worry too much about that. And I'm hoping that we remember enough from previously in the year to know that this particular conic section, which is normally going to be centered at 0, 0, is going to shift. And the way it's supposed to say 0, 0. And the way it's going to shift is by shifting 3 to the left and up 1. Because we always want to consider, whenever we have the variable inside parentheses, like in this case and in this case, we want to consider the value that makes this inside thing equal 0. And that, because that's what we want to get back to, is 0. And that's why we shift it. So since negative 3 makes this thing 0 and negatives to the left, I'm going to shift 3 to the left. And then if I wanted to get this back to 0, I'd have to have positive 1, so it's going to shift up 1. And that's going to be our new center. So that's the first thing I want to kind of mention. Before I worry about anything else, this is going to be an ellipse because of the plus sign and the squares. The center is going to shift from 0, 0, 3 to the left, so that puts it at negative 3, and then up 1, so that puts it at positive 1. So I'll go ahead and kind of mark that on my grid here. This is supposed to be the point negative 3, 1. And then from here, from this center, we're going to go left, right, or up or down using those same tricks as before. But I am going to kind of rely more on the shortcut at this point because it's going to be a little bit easier to figure out because of these shifts that are happening. So the shortcut would tell us that whatever value you squared to get this, we would have moved that way on the x-axis. So if there was no shifts at all, this would have been at 5 to the right and 5, like at 5, 0 and negative 5, 0. But because of the shift, it's going to be 5 to the right and 5 to the left of this center point. So from the center point, I'm going to go over 1, 2, 3, 4, 5. So I have a point here at where I think it's going to be 2, 1. If I had a better grid, it'd be easier to see. And then I'm going to go 5 to the left at that point as well. So that'd be from negative 3, 1, 2, 3, 4, 5. That puts us at negative 8, 1. And then as far as this point goes, I know I would square 3 to get this. So from my center point, I'm going to move up 1, 2, 3 to be at negative 3, comma 4. Whoops. And then from this point, I'll go down 1, 2, 3 to be at negative 3, negative 2. And these 4 points are going to be the ones that I connect to make this beautiful elliptical shape that I cannot apparently do freehand. So I hope that makes some sense. We're combining shifts to help us find the center, and then we're using the shortcut that we developed with the more basic ones to understand that we're going to square root these numbers and go, for the one that's underneath the x, we're going to go left or right, and for the one that's underneath the y, we'll go up or down. With a little bit of practice, it's going to seem very easy. It's also, I will caution you, very forgettable. So all the things that we did earlier in the first example to remind us of why we're using the square root of this to go left or right and why we're using the square root of this to go up or down is helpful to keep in mind in case you find yourself getting stuck. Good luck.